Will proceed in Lagrange multiplier, innovative approach in calculus. Idea was to start machine learning and artificial intelligence, but problem is that it is little bit higher. So I thought that whatever the approach we have taken, different path than the traditional, in many of the problem we should revisit prior to entering into Bayes theorem and mind-blowing neural network. As always, mathematics is the simplest of all the sciences because it is the base science. So, base science has to be the simplest, provided someone thinks step by step. Otherwise, mathematics is the most difficult one. Anyway, we are in the discussion of Lagrange multiplier. Mind blowing research by Lagrange, but there is something that is better than Lagrange, certainly. Because mind blowing research people have done in the directional derivative also. Okay, so Lagrange, what Lagrange says is that if I have a function, if I have a function, and what is the maximization of the function provided there is a constraint. So we have taken example of a function like productivity in a company, and there are two products, product A and product B. Now product A is in X number of items and product B is in Y number of items. If that is the case, then production is x to the power 2 by 3, y to the power 1 by 3. That is the production. Means production is more dependent upon x and less dependent upon y. Production of a in a company, production in the company is equal to x to the power 2 by 3, y to the power 1 by 3. X to the power 2 by 3, y to the power 1 by 3. X is the number of items or amount of a type of a raw material. This is better word. Raw material A. Raw material B. Raw material B is in number, that is y. X to the power 2 by 3, y to the power 1 by 3. This is the equation of production. Then what is the maximum productivity can be achieved? As always, I say that anyone would jump on saying that maximum production can be achieved when x is infinite, y is infinite, x to the power 2 by 3, y to the power 2 by 3, and then infinite. No. Then it is said that x, the net cost. We are talking into company way. We are into commercial calculation. The company is purchasing raw material A and B in quantity X and Y. Now, per item it costs alpha dollar for X for A, and per item it costs beta dollar for per item for B. That means the total cost is X is the amount, Y is the amount. Per item it is alpha and per item it is beta. Alpha into X plus beta into Y is the net cost to purchase the raw material. If that is the case, then total cost, total cost to purchase the raw material is alpha X plus beta Y. This cost must not exceed 3. It must be less than equal to 3. 3 is can be in $1,000,000, $1,000, whatever. So it is 3. So now if I take alpha and beta as 1, 1, then x plus y less than equal to 3. Or if someone takes some numerical value, then it will be like that only. For simplicity, because I am talking directly, so in that fashion it would be better. But someone can take some fractional value or some value, okay, like 30 cents per item and 50 cents per item, point 0.3, point 0.5, something like that. I am considering $1 per item or something like that. Then x plus y less than equal to 3 is the constraint. Okay, and productivity is x to the power 2 by 3, y to the power 1 by 3. Now, question arises, if this is the constraint, then what is the maximum productivity can be achieved through this equation x to the power 2 by 3 into y to the power 1 by 3. Now this question is molded into mathematics. From company perspective, profit and loss and raw material and buying and here and there, finally it entered the arena of mathematics. In mathematics, we have to find what is the maximum profit can be achieved when maximum production can be achieved when production equal to x to the power 2 by 3 y into y to the power 1 by 3. If that is the scenario, let's understand the problem. As always I say, it's better to put as much time as possible to analyze the problem. Because problem is not analyzed well, certainly and design, solution and testing, everything is going to be crap. So that is the scenario. Now, if someone is saying production equal to x to the power 2 by 3, y to the power 1 by 3, x and y both are independent to each other. If x and y are independent to each other, then there is a function over x and y, that is x to the power 2 by 3, y to the power 1 by 3. fxy function is nothing but z value. If I draw in a graph, z equal to x to the power 2 by 3, y to the power 1 by 3. Now I I have xy plane. In that sense, if it is xy plane, then I have this as x-axis, this as y-axis, x-axis, y-axis. Now I can keep on xy plane, and this is x-axis and this is y. It is something like this only. Okay, so okay, so this is x-axis, this is x-axis, and this is blue color is the origin. This is x-axis. If it is x-axis, then this is y-axis. It is something like this. This is xy plane. If this is xy plane, if this is xy plane, then z value is perpendicular to the xy plane because all are orthogonal to each other. Z equal to x to the power 2 by 3, y to the power 1 by 3. Then what is the constraint? X plus y less than equal to 3. What is this? Constraint means if this is xy plane, then in this domain I can take any x comma y. In this domain I can take any x comma y. X comma y here, x comma y here, x comma y here, x comma y, x comma y here, minus infinity, x comma y, anything I can take. But constraint said that you cannot take x and y anything you want. Okay, so constraint is saying that please support us. This kind of explanation is impossible someone would get in the book. Plus 91 is the India country code 94831606110. Okay, 94831606110. Plus 91 is the India country code. Now, what is the constraint? This is x-axis, this is y-axis. If that is the case, then this is x plus y equal to 3. X plus y less than equal to 3 is the reason that is in this direction. And here I have to take x as positive, y as positive because those are the numbers. So those are the numbers, they cannot be negative. So x must be positive, y must be positive. X plus y equal to 3 is this line. This intersection is 3 comma 0. This intersection is 0 comma 3. Whatever reason comes below it up to the origin, that is the reason in which only I have to select the x and y. That's it. I cannot go beyond it. So if I have taken xy plane on top of xy plane, if I draw z value, graph of z value, that is x to the power 2 by 3, y to the power 1 by 3. At origin 0, 0, the height is 0. Otherwise, in the first quadrant, we're talking about the first quadrant. First quadrant, second quadrant, third quadrant, fourth quadrant. In the first quadrant, if I keep increasing x and y, then height will keep growing. If I keep increasing x and y, then height would keep growing. I mean, height would keep growing. But I cannot increase x and y the way I want. X and y, if this is x-axis, this is y-axis, then this is the constraint x plus y less than equal to 3. Okay, this is x-axis, this is x-axis, this is y-axis. Okay, if that is the case, this is x-axis, this is y-axis. If that is the case, then sorry, this is x-axis and this is y-axis. If that is the case, then this is the constraint. Okay, this is the constraint. If this is the constraint, then every x and y must be below it in this direction. I cannot go beyond it. Whatever x and y I am selecting, x and y must go below it, but up to the center only. I cannot go in the second, third, or fourth quadrant. So that is the scenario. It must be in this region only. That is the constraint. Okay. So I have to find. Now what we are trying to find? Now let's draw the graph. X to the power 2 by 3, y to the power 1 by 3. If I draw at the origin, it is 0. Height is 0. But as I grow, it starts growing. Okay, in the first quadrant I am worrying. As I grow, it starts growing like a mountain. Okay, and when I have a constraint with a line x to the power x plus y equal to 3, at that moment it is growing. It is hitting that line. Means x plus y equal to 3. I cannot go x and y. I cannot go beyond it. Okay, if that is the case, then better I can draw. So x and y, how to tackle it? Slowly, we started with the raw material, profit and loss. Slowly, we are entering into mathematics. Now, we are trying to formulate it with the protocol of mathematics. Means it is coming in grasp of mathematics time to time. Now, if that is the case, then what we are trying to do? How I can find maximization, minimization? We know that the minimum point is origin, and from there it is keep on growing only. At one point it will hit the xy plane, but it is not a spherical that it will go in equal fashion. Somewhere it will be like this, somewhere it will be like this. At what point along the xy line? I know that below the xy plus 3 line it is lower, but as I go along it, because that is the equation, x to the power 2 by 3, y to the power 1 by 3. But as I go along, then it will keep on growing. But on top of xy line, this is x plus y equal to 3 is the line. On top of line, this 3D is not omni, that any point I can take. Somewhere it will be low, somewhere it will be high, something like that, because it is dependent upon x. So on x direction it will be higher, in y direction it will be lower. Now, at what point on this line, because I know in this line it will be maximum, at what point on this line it will be maximum. This is one scenario. Other scenario can be at the center only it is very high, and then it is going down, 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 and then it is hitting the xy plane arena, and again it is going down. What is the maximum? I am not worrying about x plus y equal to 3, because I know that maximum is happening at the origin only. What is the other scenario? At origin it is not maximum, but it is going and reaching maximum prior to x plus y equal to 3 only. It is satisfying x plus y less than equal to 3. Then all of a sudden it is going down when it is above the x plus y equal to 3. Then certainly we cannot find maximum minimum at the line x plus y equal to 3. In both cases, when at the origin only it is maximum, we cannot find maximum at x plus y equal to 3. Or in between, it becomes maximum. Still, I cannot find maximum at x plus y equal to 3. But in our scenario, certainly I am going to find maximum x plus y equal to 3. Let's take this case, how we can solve it. Now, if I go on the now what Lagrange is saying. Let's take Lagrange, what Lagrange is saying. Lagrange is saying that at each height, when I change x and y, it start attaining a height. At each height, I draw a contour line. Okay, at each height, I draw a contour line. Okay, all these problems are happening because productivity in 3 dimensions and constraint it is 2 dimensions. That is the issue. Constraint it is in independent component only. So Mr. Lagrange is saying that if this is x-axis and this is y-axis, then this is x plus y less than x plus y equal to 3. I have to find in this region. Then he is saying, let's draw contour for the height. If height is 1, x plus x to the power 2 by 3 into y to the power 1 by 3 equal to 1. If it is 1, then how it will be 1? If I say x square plus y square equal to 1, if I ask anyone x square plus y square equal to 1, can you choose value of x and y so that x square plus y square equal to 1 always? If that is the case, then he will choose a circular region. Perimeter of a circle with radius 1 would satisfy x square plus y square equal to 1. Similarly, someone has to try and find the curve line for which x to the power 2 by 3 into y to the power 1 by 3 equal to 1. Now, if this is the constraint line, then if he draws it, there may be chance that it will be underneath only. It will not touch this line. Then he will grow the contour equal to 2. X to the power 2 by 3 into y to the power 1 by 3 equal to 2 equal to 3 equal to 4. Now he will check that it must be below the line. It should not cross the line. Keep on growing till it is maximum, it is touching the line. Okay, this is what Mr. Lagrange is saying. If it touches the line, if it touches the line, then the point it is touching the line. Consider this is the curve we are getting. If this curve is touching the x plus y equal to 3, x plus y equal to 3, at that moment when it is touching, this x plus y equal to 3 becomes tangent to this curve. At that moment, if I draw gradient vector of this curve, then it is perpendicular to the curve. If I draw gradient vector of this line, then it is again perpendicular to this line. They will be parallel to each other, but they will have gradient vector. Vector has a direction and vector has a magnitude. If gradient vector of a contour is same direction with the gradient vector of the constraint line, then there can be only difference in the magnitude. Okay. Now let's calculate the gradient vector of this line of this curve. X to the power 2 by 3 into y to the power 1 by 3 plus some constant. If I take gradient vector, constant will go away. It has no use now. So gradient vector will be now 2 by 3 x to the power minus 1 by 3 y to the power 1 by 3 I plus 1 by 3 x to the power 2 by 3 y to the power minus 2 by 3 j, and gradient vector for the line x plus y equal to 3 is I plus j. Now they are same with different magnitude. So to equate it, I'll add a constant called lambda. This is called Lagrange multiplier. Now 2 by 3 x to the power minus 1 by 2 into y to the power 1 by x to the power minus 1 by 3 into y to the power 1 by 3 equal to 1 by 3 I'm sorry 2 by 3 x to the power minus 1 by 3 y to the power 1 by 3 I plus 1 by 3 x to the power 2 by 3 y to the power minus 2 by 3 j equal to 1 plus I plus j, that is the gradient of the line. Gradient vector are perpendicular to the algebraic equation. If I have a circular region, I believe these are I have already shown. So I had a circular region. Okay, somehow that circular region I was needing it. Okay, consider this is a circular region. This is the arc. If I take the gradient at any point, this is the center and this is the circular region, then it will be hitting it perpendicularly. This is the gradient vector. This is the tangential line. This is the gradient vector. If I have a line, then gradient vector will be again perpendicular to it. So gradient vector will be always perpendicular to the point in if I have algebraic equation. Now that is the case, then I have 2 by 3 x to the power minus 1 by 3 y to the power 1 by 3 I plus 1 by 3 x to the power 2 by 3 y to the power minus 1 by 3 j equal to the gradient vector of line x plus y is I plus j, lambda into I plus j, because I have to multiply for the magnitude. If lambda, if I settle it down, it becomes 2y equal to x. I have solved it in the last video. 2y equal to x. Now x plus y equal to 3, then 2x equal to 2y, then y equal to 1, x equal to 2. So at x equal to 2 and y equal to 1, this production x to the power 2 by 3, y to the power 1 by 3 will be maximum. Means 2 to the power 2 to the power 2 by 3 into 1 to the power 1 by 3. So 1 is gone. 2 to the power 2 by 3. 2 to the power 2 by 3, that is the production someone can get maximum, and that is x equal to 2 and y equal to 1. Okay, and that will lie on the constant line, not prior to it. So this is what Lagrange is saying. Okay, what is our concept behind it? What is our concept? So now we will proceed with the our concept. Our concept is says that we are trying to, if I'm trying to calculate maxima or minima, if I'm trying to calculate maxima or minima, then knowing if I say for the contour, if I'm talking about the contour, contour is nothing but x to the power 2 by 3 into y to the power 1 by 3 equal to any height. Any height, that is the contour. That is a fixed thing. Okay, so it will come as y, it will come if I see this curve, this will come as a curve. If this will come as a curve, if this comes as a curve, then I have y equal to, in term of x, y equal to fx. Now if I'm trying to find maximization y equal to fx, then dy by dx should be 0. There it will be either maximum or it will be minimum. What we are trying to do? Dy by dx, if I am calculating dy by dx, means we are trying to calculate maxima or minima with the respect of x-axis. There is a word called respect. If I have y, as fx, and if I say dy by dx equal to 0, means we are trying to find maxima or minima with respect to x-axis. Variation dy by dx means how much variation in unit seen in y direction when there is one unit of change seen along the x-axis at point x. On x-axis I can have many points. At any point x, if there is a y, if I move one unit, then y would move how many units? It may go up, it may come down, dy by dx. With respect to x-axis, if that is the case, if I say dy by dx, I get maximization and minimization with respect to x-axis. Here, unknowingly, we are trying to calculate maximization, minimization along an axis, that is x plus y equal to 3. This is fit case for directional derivative along a vector. Dy by dx is a directional derivative along vector I. That is a special case of directional derivative. Directional derivative is a big thing. We are trying to find right. This is the exact answer of this problem. Rather than lambda and setting it a vector magnitude and this and that, not really. Now, if you see the book, then Lagrange talks too many things. When you solve a problem, try to minimize the number of variables. If it is x and y and z, try to bring it lower, come to one variable and then tackle it. Lagrange is introducing variable to variable, and he is falling like, then what is the lambda relationship with this, and many things he talks. As if lambda is in the problem domain. Okay, it is a fit case that if I have a equation x to the power 2 by 3 y to the power 1 by 3 equal to something height, that is a contour. This is a fit case where y equal to fx. If that is the case, then what is the maximum value of y can be achieved along a line x plus y equal to 3? What is the maximum value of y? The maximum value of y can be achieved along the line that is y equal to 0, that is x-axis. Okay, this is fit case of directional derivative along a vector. Now we are trying to find directional derivative along the vector x plus y equal to 3. What is the vector form of x plus y equal to 3? What is the vector form of a circle? Where this? Oh, what is vector form of a circle? What is vector form of a line? Okay, then only I can proceed on it. So if this is a circle, then if I talk about position vector, it is centered at the origin, then this is the position vector, which is perpendicular to the circle. Okay, this is the position vector, this is how it is moving. If I calculate, the gradient of this position vector, I'll get the surface. Okay, or if I have a circle, directly can I calculate the tangent vector? This is what we want. Either you get the kind of position vector and then calculate the gradient of it. Either someone can calculate the position vector and then calculate the gradient of it. Okay, position vector and then calculate the gradient of it. Or someone can find the tangent line for the circle. Or if I take this line, what is the equation of this line? Tangent to this line is the line itself. For a straight line, tangent is same, but for a curved line, tangent is like this. It is little different. What is the tangent equation? I believe it is known. It is dy by dx. That is the tangent formula. Dy by dx, then y equal to dy by dx into x. Okay, that is the formula of the tangent, or I vector plus dy by dx j vector. Now, if this is the line x plus y equal to 3, then dy by dx equal to minus 1. Then xi, then it is I, then the kind of the vector that is along the line is I minus j, I minus dy by dx j. What about circle? Circle is x square plus y square equal to 1. What is dy by dx? What is y? Y equal to, if radius is a square, then a square minus x square square root. Dy by dx is minus x by square root of a square minus x square minus xyy. So the tangent to this, that vector will be I minus xyy j. Yi minus xj is the vector. Here it is x plus y equal to 3, then y equal to minus x. Dy by dx equal to minus 1. I minus j is the vector form. Anyone can, if someone has better explanation, he can talk about it. I have another way also. Like position vector of any line or circle is xi plus yj. Someone can proceed on it. If it is a circle, then x plus y, I would do. Right now, we are in form of calculating the directional derivative along vector. What is directional derivative along vector? Vector v. Directional derivative of any function fxy along vector v. This is known is gradient vector of fxy dot product with the unit vector along the v. That is directional derivative. We have tons of video where we have proved it, that how directional derivative is directional derivative of algebraic equation along a vector is 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 gradient vector of that algebraic equation dot product, the vector dot product with the unit vector unit vector along the vector. So now I have vector I minus j, then unit vector is I minus j divided by square root of 2. Dot product with the gradient vector. The gradient vector is 2 by 3 x to the power, now there is no lambda, 2 by 3 x to the power minus 1 by 3 y to the power 1 by 3. Okay, that is I plus 1 by 3 x to the power 2 by 3 y to the power minus 2 by 3 j dot I minus j by square root of 2. Okay, this is the directional derivative along a vector I minus j. This should be 0 for the maximization and minimization. If I want maximization and minimization along x-axis, then dy by dx should be 0. If I want maximization, minimization along any vector v, then gradient vector dot unit vector along v should be 0. Or dy by dv or dy by du. U is a famous word for the directional derivative. So our u vector is I minus j. Unit vector is I minus j by square root of 2. Then gradient vector dot unit vector of u, that is dy by du. Dy by du, directional derivative of y or fx along any vector u. Dy by dx, dy by du. Dy by du has this formula. If that is the case, then we are landing up directly into the same situation, where now 2 by 3 x to the power minus 2 by x to the power minus 1 by 3 y to the power 1 by 3 equal to 1 by 3 x to the power 2 by 3 y to the power minus 2 by 3. Settle it down, y equal to x equal to 2y. This is what someone would get. X equal to, I believe I am right. Okay, x to the power minus 1 by 3. Yeah, right. So x equal to 2y. We will see now there is no question of lambda. Then there is no story beyond the lambda. There is a big story beyond the lambda. That how lambda would vary with this, how lambda would vary with that. Then Lagrange came up with the Lagrange vector, Lagrange equation, so many things he did. Now convert into Lagrange function, Lagrange vector, and it will be easy in the fashion. Nothing is required. Simple directional derivative. Someone calculate maximization and minimization. We will talk more on it, and we will take few example more on it. Quite simple, right? Just find the vector along which we want the maximization, minimization. Find the gradient vector dot unit vector equal to 0. Solve it. Maximum 10 seconds. That's it. Rather than going full story. Problem with Lagrange problem is that he did not understand the problem well. This is what I can say. That's why he is meandering here and there and trying to capture the solution. And then he is keep on meandering. Anyone can read the book. Too many things he is inventing unnecessarily. When someone has already invented directional derivative. And what invention? It is a part of calculus only. Dy by dx is a special case of directional derivative. Directional derivative is a big thing. Directional derivative, line integral, surface integral, these are the generic things for which we have special case as integration along x-axis or integration along xy plane. These are special cases. So these are a case with a vector, powerful. So we will see more example. Please do support us. It helps us. Plus 91 is India country code 9483160 plus 91 9483160